Hello and welcome back. We are going to start on section 2 of chapter 1, talking about science. Okay, so the first thing we're going to do is we're going to look at the scientific method. Now I know you say, wow, I've done the scientific method for years, but let's just review it real quick. Alright, so everything starts with an observation. Okay, scientists for many centuries have been observing things. They do an observation, and they end up with a question. Okay, why does the sun rise? Why does water look blue? Okay, so they always come up with a question. The next step would be to research. You want to properly start looking up things that pertain to your question. Why does water look blue? You could be looking at things like how light behaves, light wavelengths, things like that, water molecules. Alright, after you do your research, you can form a hypothesis. Okay, so this is a prediction of what's going to happen. Okay, now, of course, once you have a prediction, your next step would be to test it. Okay, and when we test things, we generally use experiments. In our experiments, we have what's called a control, which is something we don't change, and we have a variable, which is something that we change. Now, in experiments, what's really important to remember is that you only have one variable. There's only should be one thing that you ever change. So, we're going to use these experiments and we're going to test our hypothesis. While this is happening, we're going to make more observations. When you're doing an experiment, you should be jotting down some notes and observing what is going on in that experiment. After the observations, we can then make some kind of conclusion. So we can conclude the experiment, we can see whether it supported our hypothesis or whether it did not. Keep in mind, experiments fail. In fact, it's from failure of experiments that we have DuPont paint. Okay? It's these failures that lead us to new discoveries. So, if your experiment doesn't go as planned, backtrack, look through your research, look at your data, look at your math. Did you calculate correctly? Okay, so this is sort of a general method that we follow. It kind of keeps us straight on how we need to approach solving a problem. Because when we're solving problems in science, we have to use critical thinking. Okay, that is a combination of taking in all the facts, making observations, and tying everything together to come out with a result. Okay, so this is just a general guideline. Sometimes we might be doing an experiment, come to an observation that was totally what we didn't expect, and have to go back and research. So this is not set in stone, the order that you do this in. Okay, so we're going to move on from the scientific method into some special things that scientists use to help with doing some of their experiments, some special types of equipment that are pretty neat. So let's look at the radio telescope. Okay, the radio telescope, it detects radio waves. Now, radio waves are electromagnetic waves, so that means they can travel through space. So, objects in space that are giving off radio waves can be detected by these radio telescopes and can give us an idea of what is out there. Another special tool we use is a spectroscope. Okay, it separates light. If you ever wonder why they say certain stars are what temperatures they are and things like that, they can use it by separating the light that the star is giving off. They can also calculate to a pretty good degree of accuracy how far away that star is. And we learn that by using light. Okay, so this sort of separates it into the rainbow. We learn what the substances make up these stars. Okay, the third kind of really neat tool they can use is called a particle accelerator. Okay, and what it does is it actually makes parts of the atom move very, very fast. And in doing this, they can crash these pieces into each other and stuff and learn about different types of atoms and the makeup of atoms. So there are some very specialized tools out there that scientists use to learn about not only our planet, but about our universe. Now, the last thing that brings me to in this section, and we will do plenty of this in class for practice, is SI units. Okay, SI units are the units we use in science. They are standard international units. It is used all across the world, and it is a good way of measurement for a couple reasons. One, it's based on tens. So it's not very hard to calculate them. A lot of times you're just moving a decimal. The second reason it is very good to use SI units, especially in science, is because when I measure something and I'm using SI units, a scientist from anywhere in the world can look at my measurements and not only reproduce them, but know the exact measurements that I'm using. Okay, so say I'm using feet. Well, a scientist on the other side of the world might not know how that a foot is 12 inches. Okay, but in using the SI units, scientists can communicate with each other all over the world. Well, that concludes this video section. And like I said, we will be practicing using SI units. We will learn more about them in class, and we will practice converting them. Have a good evening. Bye.